For my thesis, I looked at the impact of rising sea surface temperatures on the small island developing states. Specifically, I looked at their economic output. My name is Josef Benzaoui. I'm a BA student here in the economics department at Boston University. So I knew that for my project, I wanted to look at something that allowed me to understand the relationship between the natural environment and the human economy. And so that meant I needed to be able to come up with a small and specific metric for climate change that can be measured and that also has some sort of output and impact on the human economy. And so in that case, I looked at rising sea surface temperatures, their impact on coral health, and then in turn the impact of coral health on small island developing states. So before we talk about my project, let's understand coral bleaching, and let's also understand how coral operate. So coral live through a mutualistic relationship with algae. Algae live in the tissue of coral, and in return, the algae provide roughly 90% of the organic compounds that the coral need to survive. And they also create the very bright, vibrant colors that often attract tourists. And so when coral becomes stressed, and this is often due to changes in water quality, and specifically we're looking at changes in sea surface temperature, they will expel the algae from their tissue. And when they expel the algae from their tissue, they lose their life source and they also lose their source of color. And that's why it's called coral bleaching. As you can see in the picture, it has very much a bleached look. So to summarize what we know that increases in sea surface temperature lead to coral bleaching. That's shown in biological studies. And what the purpose of this project is to analyze then the impact of coral bleaching on tourism and fishing, and then also the declines in tourism and fishing, if they exist, on decreases in GDP. So what is the consequence of coral bleaching? So there are many, but let's think about first what coral reef ecosystems are. So coral reef ecosystems are a form of natural capital, and natural capital is the stock of assets that exist in the world, such as soil, air, or water. And so many of these ecosystem services that they provide create non-market and market benefits to the human economy. And so in this case, coral reef ecosystems, they provide benefits in the form of fishing and tourism. Coral reefs provide a habitat and improve the reproductivity of fish, which increases the fish supply, and they also have the vibrant colors that attract tourists. So what did I do? I assimilated data for economic indicators such as GDP, labor supply, population, as well as coral health and sea surface temperature for 23 small island developing states, which I'll refer to as SIDS throughout the presentation. And this was from the time period of 1983 to 2007. I then performed time series econometric analysis using a statistical software known as Stata. And the gist of this is that it allows me to control for any unobserved variation across time and countries in the data. And I did this to look for statistically significant relationships between these variables. And then I analyzed the results and translated them into a real-world narrative and wrote a 70-page empirical economics paper. So to get a better idea of what the data is, we can visualize it here. So this is a map that shows clusters of coral reef formations. And so the data has longitude and latitude points for coral, and that allows us to plot these specifically at a high resolution for these countries. And in turn, we also have longitude and latitude points across time for where coral bleaching events occur and how severe they are. And then we can use that to construct a coral health index, which starts at a perfect value of 1 and then declines as these bleaching events occur. And here you can see it across time and countries. And most importantly, we can connect it right back to sea surface temperatures because, again, now we have sea surface temperatures with longitude and latitude points across countries and time. So again, the two key the two industries here we're looking at, tourism and fishing. Tourism can be anywhere from 15 to 20% of the GDP in these SIDS. And fishing is usually a little bit lower, but it can be up to 10% in these SIDS. So right to the results, we had a model for GDP, and we used the data to estimate that model. And we found that a 1% decline in coral health is associated with a 1.1% increase in GDP. So the story here is unsustainable economic activities, in which perhaps the economic activities in these countries are degrading coral health. And so that's supported by the fact that we see that higher GDP per capita is associated with declines in coral health. So let's now consider fishing and tourism specifically. But before we get there, I just want to mention some data limitations. The Coral Health Index relies upon a large number of observations across time and a geographic space of a country. We have a very limited number of observations, which means our index is probably overstating coral health in these countries, which then in turn means any decline in coral health is marginally understated, which is then overstating the impact of coral health on changes in these economic indicators. And so for that reason, we also consider average bleaching severity, which is just the average of the damage in a given country and year, which might be a little bit less biased than the Coral Health Index. So let's talk about Fish Catch and GDP. This is probably one of the more interesting stories. If you consider the impact of a decline in coral health in the given year or the prior year, you see that declines in coral health are associated with higher levels of fish catch. Again, this is the idea that fishing practices may be unsustainable and degrading coral. But what's interesting is when you consider both the coral health in the current year and the prior year together in conjunction, you find that still declines in coral health in the current year are associated with higher levels of fish catch, but declines in coral health in the prior year are associated with an even larger decline in fish catch, which means that the impact of fishing in a given year may be degrading coral, which results in less habitat and poorer reproductivity for these fish, and then that is coming into play the next year and harming fish catch. Now, for tourism arrivals, again, we looked at both the impact of coral health and average bleaching severity. Neither of those had any sort of significant relationship or impact on tourism arrivals. But this is likely due to the fact that tourists simply aren't aware of the extent of coral bleaching, and it's likely not an important factor in the decision-making process when they want to decide where to go for vacation. But what's interesting is that GDP per capita is significantly associated with tourism arrivals, which suggests that the relative wealth of these nations is an important factor in tourism decisions. And so this is something we'll come back to later, because if GDP per capita impacts tourism arrivals, the question is, will this coral health impact GDP per capita? And so this is where the interesting part comes in, is that there might be a difference when we consider the levels of GDP and the growth rates of GDP. Because as we've seen, in the short run, we're noticing declines in coral health are coming along with increases in economic output. But is there a different relationship when we consider the long-run trends? And so there is. There's a lot of numbers up there, but the big point is that declines in coral health are also associated with declines in the growth rate of GDP per capita. And then remember that declines in coral health were associated with higher levels of GDP. So we're seeing that although declines in coral health are associated with higher economic output, this is actually harming the relative wealth of individuals in these nations over time. And what's really important is that these numbers really seem small, but we need to understand what is the average growth rate of GDP per capita from 1983 to 2007 for these countries. The average is 0, with a median of 4%, which means that there's likely a smaller number of countries which are exhibiting lower levels, almost, I should say, negative levels of growth rates, negative growth rates of GDP per capita that are skewing that result down. And so perhaps some countries are being disproportionately impacted by coral health in terms of their long-run growth. So bringing it back to sea surface temperatures, we find that a 1% increase in sea surface temperatures is associated with a 27% decline in coral health. This is a little bit of an outrageous result because none of our countries actually ever exhibit a decline that large. The lowest our Coral Health Index falls is roughly 0.8, which is a 20% decline from the perfect value of 1. And this goes back to what I said about the lack of data. Because we have a lack of observations of coral bleaching, the Coral Health Index is likely overstated. So any decline in coral health is overstating the impact on economic indicators. And this is, again, the same with sea surface temperature data. We have real data on sea surface temperature data that's accurate, but inaccurate data on coral health. So this sea surface temperature increase is likely overstated, but true, just a different but in lower number. We also find that increases in sea surface temperature follow that lag story in which the current year has an impact Rises in sea surface temperature in the current year do have an impact, but the lagged impact of sea surface temperature is even greater. However, these results are statistically insignificant, but this is likely due to the fact that we have such limited observations, which is usually around 50. And I believe if we had more observations, these results would hold and be statistically significant. So in conclusion, we found that sea surface temperature has a negative relationship with coral health. We see that fish catch has a present and lagged impact, or relationship, I should say, we can't claim impact, on coral health. And most importantly, we see that coral health is a negative relationship with the overall level of GDP, but a positive relationship with the growth rate of GDP per capita. So in a more of a narrative format, this is again contributing to the claim that these countries rely upon unsustainable, say, fishing practices or other economic activities that are degrading their coral, boosting their economy in the short run, but over time resulting in declines and impacting the relative wealth of these nations. And the biggest takeaway, I think, is if we had another 20 to 30 years of consistent data, we would see really statistically significant results, and we would probably see more accurate results. Again, there's a lot of data limitations related to the fact that there's, one, not a lot of data, and two, the metrics we use are not totally accurate as a result of the fact that they're not consistently updated across time, and they're not a representative number of points across coral reef formations in a country. But I think the results would hold true and with another 20 to 30 years of data and be statistically significant. And so I think this really highlights the need for, one, more consistent observations of coral health, and also two, more consistent recording of economic indicators for these countries, because my time period was highly limited from 1983 to 2007 instead of something like, say, 1970 to 2017, because a lot of these countries do not have quality updated statistics on their economic indicators. Thank you. Questions?
What are some of the specific indicators that you would point to as being representative of like the GDP growth? What specifically would you look at?
When I say economic indicators, I mean the values such as GDP, tourism, fish catch, and then also a lot of those are control variables that I include in the models, like what is the labor supply in these countries, what is the total population. GDP per capita is something you always want to control for, because the relative wealth of these nations and activities is something that may impact your results. You know, if one country is much larger than the other, you might see more coral degradation simply because there's more people and more activity occurring.
In those countries, though, you're dealing with a lot of barter economy, and you're not picking that up in your statistics.
That's true. That could be happening.
Have you thought of any, just curious, have you thought of any other, specific relations you might want to study after this that, you could see where negative impacts or where you could, I guess, assess unsustainable, economic practices in terms of relations with the economy, or?
Yeah, well, I mean, it's along the same lines. It's more, I need to be more narrow and specific, because the claims that coral health is impacting GDP at a country level, even for these reef-bearing small island developing states, is a little bit large, and it might be better to specifically narrow down just considering fishing and tourism, because those are much more specific than GDP as a whole.
So do you think this information would be interesting for these for the small island developing nations to make their own policy changes, or do you think this is more applicable to a more I would say maybe a coalition like the United Nations or something, when they're sort of considering taking climate action?
I mean, it could be relevant. I mean, it would be interesting to policymakers, and it could be relevant to the individual countries. But again, I think they would be more interested in perhaps analysis specifically at a country level, because even though we're only looking at 23 countries, that still is creating an aggregation that might not be relevant to any individual country. A given example would be about what is the growth rate of GDP per capita in some of these nations. Some of them, with an average of 0 and a median of 4%, clearly some of them are in the negative and some of them are in the positive. So this might not be totally relevant. I think in order for a specific country to want to be considerate of this data, this would need to be done at a specific country level rather than 23 countries. But again, there's probably not enough data to do something like that that is believable, for these countries. You'd want to be able to extend accurately from 1970 to, say, today rather than just 1983 to 2007. Any other questions? Thank you.